In problem 4, we're looking to construct an angle with the same measure as angle C, but has sides that are twice as long. So what we're going to do is we'll first start with just a segment length. We'll identify our endpoint to be the point C, our new angle C. And so looking at this, what we want to do is copy this angle. Well, to copy the angle, what we're going to do is place our compass on the vertex of the angle we're copying, and we're going to create an arc that passes through both sides of that angle. We're then going to duplicate that arc onto our construction, and we exaggerate it. So make sure that this arc is exaggeratedly longer in length or greater in measure than the other given arc, the original arc. And then what we're going to do from the intersection, we see that it intersects what is equivalent to this lower segment. We place our compass tip on that intersection, and then we measure the distance from this arc side intersection to the other arc side intersection. And so if we measure that and mark it, what we can now do is go to our duplication at the one arc side intersection that we have, and if we construct an arc, we can duplicate this distance from arc side intersection to arc side intersection. And what that then allows us to do is it allows us to extend a straight line through that. And so now I've duplicated angle C. The second part to this problem is to create side lengths that are twice as long. So I'm first going to measure the distance from B to C. So here's the measure from B to C, and when I mark this off, I'm going to mark it off 2 different times. So there's once and twice. So now my new side B right here, I call it B2, is twice the length of BC. So I'll darken this in and draw it in with a darker color. And then for CD, I want to duplicate that and double its length as well. So if I place the compass tip on one endpoint, adjust my compass so it passes through the other. So now my compass is set to the length CD. And if I mark this off again twice, there's once, here's a second time. So now if I assume this is my new point D, that's double the length of the original CD, I can connect that back to my vertex, and so now my angle in black here from D2 to C2 to B2 is twice the length of the sides of the original angle, and the angles themselves are equal.